Okay, in this question here, we have the length of her swing is 1.75, but she is going to increase the length of her swing to be 3.1. So it's going to now become 3.1. I want to algebraically determine the central angle to the nearest tenth. Now, in our last example, we already calculated the radius. So let's go back to that. The radius we already determined, and I'm going to use my unrounded version. So the length of the swing or the chain on the swing, the radius, was 1.14854086. That's not changing. She just wants to swing higher, which means she's going to have to go at a higher angle. Okay, so theta is equal to arc length over radius. So theta is going to be her new arc length, 3.1, over the radius of 1.14854086. Now, this angle is going to be in radians, and then they want us to switch it into degrees. So I'm going to start first of all with our angle in radians, and then I'm going to switch that into degrees. Okay, so let's start with our radians first. We'll go into our calculator, and I'm going to take 3.1 and I'm going to divide it by that arc length, which was the unrounded from part A. So that's 1.148540 and 826. So this is my angle in radians, okay? So about 2.7 radians. So 2.7 radians, but we want it to go in degrees. So I'm going to take the 2.7. I'll actually take the unround 2.7. And since I want to go 2 degrees, that means that my degrees go on top for my multiplication factor. So it's going to be 2.7 times 180 over pi. Of course, I'm going to use my unrounded version. So I'm going to take this and I'm going to multiply it by my multiplication factor. 180 goes on top and then divided by. And that would be my answer in degrees. So let's see how we're supposed to round it. Back to the question. And it says measured in degrees. It doesn't say, so let's do it to the nearest tenth. So we'll say that that angle in degrees would be 154.6 degrees, or to the nearest whole degree, it would be 155.